Welcome back. Welcome back. It's Learning with me, Miss Killen here at MPB. I'm so excited that you came back. We are almost to the end of Unit 1, but we're on Lesson 6. So Lesson 6 tells us we're doing rational and irrational numbers within different operations. I can use rational and irrational numbers within an operation while generalizing on their relationship between them. I'm also looking at standards in RN3, and like I said, we are still in Unit 1, almost finished. So let's look. So here's a big question. What is rational and irrational numbers? How can I tell the difference between them? Well, we went over some of this in our last session, but one true way to look is numbers can be represented as a fraction, and your denominator cannot be 0, and these are called rational numbers. Now, we have been learning, probably since we started having math classes early in elementary, you cannot divide by 0. So that's why I went ahead and put that in there, just to make sure that we're remembering that. Also, it says numbers that cannot be put into a fraction are called irrational numbers. Now, we looked at some of those, remember when we went into the calculator and we couldn't make them into a fraction, but we also have well-known irrational numbers. So I want us to also look at those as we go along. So here we go. It says, so what can't be put into a fraction, which is pi, it never ends, non-repeating numbers, they are called non-terminating. And then when we take the square root of any natural number, that is not a perfect square. Now, you're looking at those notes and you're saying, Ms. Killen, I've got some questions on a couple of those words. I knew you would. When we look at this word right here, non-repeating, that means it is non-terminating. Well, Ms. Killen, I'm still not quite sure what that means. Okay. When you get a job or you've had a job and your job is terminated, what happens? Your job stops. Or let's say you have a subscription to something and the subscription is terminated. What happens? The subscription stops. So then if I had a terminating decimal, meaning my decimals stopped, that could be considered a rational number. We're talking about those numbers that are non-repeating or non-terminating. Well, Ms. Killen, what's that look like? Let me show you. Let's say we had 3.276549317 blah, 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 blah. Those dots tell me it's never going to stop, ever. They're never going to stop. They're just going to keep going on and on and on. And they're never going to start repeating. Well, Ms. Killen, I don't really remember what repeating numbers look like. Let me show you. Let's say that we had 14.373737, and I put a line there. So then that line tells me that it's a repeating decimal. We can put those in a fraction. We learned that our 8th grade year in math. So we know how to put repeating decimals in fractions, but when we have the non-repeating and the non-terminating, those are irrational numbers, along with pi. Everybody knows pi, 3.14 is not pi. That is part of pi. Now, when we learned that 3.14 in elementary school, that's really all that we could do. But pi goes on and on and on. If you look over here, whoops, sorry. If you look over here at this circle, pi keeps 3.1415 and on and on and on and on, and it keeps going, okay? So when we see pi, it's never ending. Those wonderful genius mathematicians cannot find the ending of pi. That's why we call it a non-terminating number. Good job. Now, Ms. Killen, what about those natural numbers you're talking about? When I talk about natural numbers, it's all the numbers that I see in nature. I see 4 cows or 3 people or 2 dogs. I don't see 1 3/4 cows. I see a cow and a steak. You can't have a part of something in nature. Well, what about that 3.5 that I see down the road? No, you see 2 trees. One is full height and one's really short. So we can only have those whole numbers in nature. That's what it's talking about, natural numbers, those numbers that we see in nature. That was a good question. So let's keep going. All right, look at this table. It says find out fill out the table to indicate rational or irrational. And I may need to use my calculator. Well, Ms. Killen, I see the square root of 9. 9's a natural number. Yeah, but is it a perfect square? Is it? Let's see. Y'all grab your calculator. Now we learned how to put in the square root symbol. So I'm going to put the square root of 9, and what do you get? I get 3. So 3, can it be put into a fraction? You sure? If I take 3 and I put a 1 under it, that is a fraction. It doesn't change 3's amount, it just shows it as a fraction. So since I can put it into a fraction, it's a what? Yes, it's a rational number. All right, what about the square root of 8? Go ahead and plug that into your calculator. So I'm putting my square root symbol in 8. Well, Ms. Killen, I got a decimal number. I did too. So go ahead and put math 1 to see if I can turn that into a fraction. Let's try. Math 1, or math enter, not 1 but enter. I get a decimal again. So it's going to be irrational. What about 3 or 33 over 8? It's already a fraction. So since it's already a fraction, what can we say? It's a rational number. All right, look at this next one. I have 8.7963. Well, what's over that 63? What does that line tell me? It's repeating. What did we learn about repeating numbers? That we can put them in fractions. And since they can be put into fractions, that means they are rational numbers. What about 22 over 4? Yes, that is rational because it's already. All right, 7.613259 ... What do you say those ... dots meant? It keeps going and going. It never repeats. It never terminates or stops. So it's going to be irrational. All right, -17. It's a negative number, Ms. Killen. Okay. It can still be put into a, yes, it can still be put into a fraction. -17 over 1. There we go. So it's going to be rational. Pi, and I don't mean peach or apple. Pi is irrational. They have yet to find out where it stops. Now what about the cubed root of 8? Now we learned how in last session how to put that cubed root in. So everybody in your calculators, put the cubed root of 8 and let's see what we get. So I go to my math, I go down to the cubed root and put a and enter. I get a 2, I get a whole number 2. Well, we know if we take a whole number and put a 1 under it, it's a fraction. So that's going to be rational. What about 12 to the 4th? There's an exponent, Ms. Killen. What do? Well, let's see. 12 to the 4th is 20,736. Can I make that into a fraction? Yes, I can. So that one is rational. What about 19.503? Well, Ms. Killen, it's got decimals. It does have decimals, but what's that one thing that we notice about that decimal? It stops. So I could write that as 19, 5 over 3 over 1,000. It's a mixed number, but I can still turn that into a fraction by multiplying and adding. So it can be also a rational number. But what about the square root of 2? Take the square root of 2, I get a long decimal, so I go back and press math, enter, and I get the same decimal. So that means it can't what? It can't be a fraction. So this one is going to be irrational. Good job, guys. So let's look at the next part. If you have 2 rational numbers, when you add, you always get a rational number. Now, this is key important. I mean super, super, super important. Rational plus rational equals rational every single time. Today, tomorrow, 12 years from now on a Thursday at 3:33 in the afternoon, it's still going to be a rational number. So let's look at this one and let's work this problem. So I have 1/2 plus 1/4. I'm going to make the same denominator. So 2 plus 1 is 3 over 4. It's a fraction, so I would say that is rational. All right, so let's look down here. I have a decimal and I have a square root symbol. Well, Miss Killen, what do? Turn the decimal to a fraction. When I have 0.5, that's a what? That's a half. Well, I know what that fraction looks like. So I have 1/2 plus, well, what's the square root of 4? You're right, it's 2. So then 1/2 plus 2, there you go. So this is also rational. Okay, Miss Killen, I need you to stop for a minute. Okay. Just because I see a radical sign does not mean that it's irrational. No. You always put it in the lowest terms. You may be able to put that radical, square root, cubed root, 10th root into your calculator and get a rational number. So just because you see the radical sign, don't say, okay, stop, it's irrational, can't do it. No. You go through the process of doing the math and seeing if it's rational or irrational. All right, here we go. If we have two rational numbers, when we multiply, we always get rational numbers. Here's another important fact. All right, so I have 4 times 5. 4 is rational, 5 is rational. When we learned our multiplication facts, which we should have learned, 4 times 5 is what? 20. That is a rational number. Well, look down here. I have 1/2 times 1/3. And when we multiply fractions, I multiply straight across. 1 times 1 is 1. 2 times 3 is 6. That is a fraction, so it is rational. And then -17 times 2 is going to give me a -34. And I can put that over 1 and make it a fraction, so it is rational. So I have 3 examples that tell me when I'm multiplying, I'm always going to get rational if I'm multiplying with rational numbers. Now it says, what can we say for a fact about these? Even if I get a whole number, I can always put a 1 under that number and make it into a fraction. You need to make sure that we're remembering that. If I get a whole number, I can put it over 1 and then I can say it's a fraction. All right, so let's go. If we have a rational number and an irrational number, when we add, we will always get an irrational number. Well, Ms. Killen, are you sure? Well, let's see. Pull out your calculator. We're going to put 4 plus the square root of 30. So I'm going to pull up my calculator and let's look. So here we go. I've got 4 plus the square root of 30. Get a decimal, but don't worry. We're going to see if we can turn that decimal into a fraction by doing math, enter, enter. And I get a decimal, so that is irrational. Let's look at the next one. Let's see, the next one says, I have a fraction, so to put a fraction in your calculator, you're going to hit the green button, and then you're going to hit your y equals feature. That n over d means numerator over denominator, so I'm going to hit the number 1, and there's my fraction. I'm going to put 4 over 11. I'm going to scroll out of the fraction and put plus. Now, pi. Pi symbol is on our calculator. If we look under the clear button, which is my exponent key, I see a blue pi. So for me to have that pi pulled up, I'm going to hit my blue key or my second key and hit pi. There we go. And I'm going to press enter. I get a fraction, but what I'm going to do is I'm going to put in my math key to see if I can turn it to a fraction. So let's look. I have math, enter, enter, and I still get a fraction. So I know for a fact it's not a rational number. It's irrational. So we have 2 examples. This one was irrational, and this one was irrational. And our calculator showed us, because we could not turn it into a fraction on the calculator. So those were 2 very good examples. It says if we have a non-zero rational number and irrational number, when we multiply, we will always get an irrational number. Okay, Ms. Killen, now we're multiplying. So can't that be a little different? Well, let's see. Let's pull up our calculator again, put these two problems in, and let's find out. You get yours. I'm going to pull mine up on the screen, and here we go. So I'm going to put 6 plus the square root of 6, enter. I get a decimal, but we're going to check it. Math, enter, enter. Nope, I still get that decimal that can't go into a fraction. So let's try the next one. The next one was 1/2, so I'm going to hit alpha y equals, hit the number 1, and put 1/2. Using my scroll keys, I'm going to scroll out of the fraction, and I'm going to put multiply by the cube root of 2, which is math. I'm going to hit number 4, and I'm going to put 2 and enter. So I'm going to hit math, enter, enter, and I can't. Now, Ms. Killen, when you put that first one in, you put a plus symbol. You're right. I put a plus symbol. So I need to go back and redo that one. Well, Ms. Killen, I don't really feel like pushing all those buttons again. You can recall on your calculator. Let me show you. So I'm going to scroll up to where I want to go. And there we are, 6 plus the square root of 6. I'm going to press enter. I'm going to scroll left, and instead of the plus symbol, I'm going to hit multiplication and enter. So that's 1, how we can recall, and 2, how we can check this. Now let's see if this one will turn into a fraction. It won't, so it's irrational too. So not only did we see with a calculator that both of these are irrational, but I also learned I can recall or pull things back up from my calculator. Good job. All right. Now, let's do some practice. It says circle the correct word to complete the statement. So my statement that I'm looking at is 3 plus the square root of 2. So it says the expression represents the blank. Is that a sum or a difference? So I'm going to say it's the sum of a 3 is rational, but the square root of 2 is not. So I'm going to put irrational. So when I add a rational and irrational, I'm always going to get irrational. Now let's look at this second problem. I'm going to read it. You read it on your paper. So here we go. The square root of 4 plus 3/5. This expression represents a what? Sum or difference? You're right. It's a sum of a or an. Now, is the square root of 4 rational or irrational? It is rational. And 3/5, is that rational or irrational? That is rational. So when I take a rational and add it to another rational, I always get rational. Good job. Now let's look at 3. 1.256 times the square root of 16. This expression represents, is this a sum or a product? It's a product because we're multiplying. Now, 1.256, we know we can put that into a fraction, so it's rational. But what about the square root of 16? Well, if I put that in my calculator, the square root of 16 is 4, so that's going to be a rational number. So it's equivalent to a rational number. Boy, y'all got this down pat. That's really good. So let's look next. Nope. All right, so here we go. Now it's time for you to master. We will use x and y, which are non-zero rational numbers. I'm going to annotate my problem. X and y are rational numbers. So then it says that z is going to be irrational. Use the variables in each operation and determine if they are rational or irrational. So now that we've annotated our problem, stop the video. You and your table partners work on this, come back to me, and let's see what we got. All right, so let me see what I can do. You check my work. So y is rational, z is irrational. Well, when I subtract them, I am always going to get irrational. All right, so x we said was rational, y is rational. And when I multiply rational times irrational, I'm always going to get a rational number. So I have rational times irrational. Yes, I am going to get irrational. So what happens when I add a rational and irrational? I get a rational number. What happens when I multiply a rational times an irrational? I get an irrational number. Now I have a rational over a rational, or I have a rational divided by a rational, and I get a rational number. So what happens if my rational numbers are negative? Doesn't matter, they're still rational, and I'm going to get a rational number. Whew, that really made me think about those rules that we've learned. Something that I don't want us to forget. What it means for a number to be rational, and we have those rational plus rational is rational, rational plus irrational is irrational, and rational times rational is irrational. Rational times irrational is irrational. What does it mean for it to be irrational? It means it can't be put into a what? A fraction. Good job. I'm so glad that you came to learn with me today here at MPB. I'm having a great time. We're almost at the end of our unit, so don't worry, we're going to get there. I want you to have the best day ever.